Everybody together? Cool. The stool, oh, it's here. It's really hard to like type when the computer is below a certain height. So I need to sit down. Okay, so this is RStudio. I know it sounded like most people had a little bit of experience in R. Has anybody not worked in RStudio before? It's like completely new. Okay, a couple people. So in RStudio, when you open that rproj, you're going to see what's in the folder here. Again, if you don't see anything here, you didn't open the rproj, you opened something else. So RStudio is a front end for R, right? So you have R, which you have to download separately. And then RStudio is a front end for it, which allows you to use it. You can write code in R, just like if you open R, it'll just open up a little text box and blink at you, right? This makes it easier to do. You can also use, people use Visual Studio, I think it is, from Microsoft. It's broken up into these 4 panels. You can change what's in those panels. This is what's there by default, and so I'm going to leave it that way. Down in the bottom left here is you have your console, which this is R, right? So if you like type stuff in here and hit run, it's running, R is running. And so when we take stuff and click run or say run from up here in our document, what's really happening is it's taking it and putting it down into the console and running it. You also have a terminal tab. This is like your command line for your computer, like your base computer. We won't really do anything in there, but that's what that is. And we don't need to worry about background jobs. So whatever document you have open is going to come up in this window here in the upper left. On the right-hand side, the most important thing is this environment tab. This is what you're going to have in your environment tab is like if you read in data, that's where you'll be able to see that you have data read in, and you'll be able to see variable names and that kind of stuff. And then down on the bottom right, we're mostly going to be in the files tab. Again, that's going to show you what's in your project, like what's in that folder. So this is really important for like when we read in data, everything's case sensitive, super sensitive. So you're going to like copy that, from there. If you're running code straight in the console, any plots will spit out over here in the plots area. We're going to be working in markdown files, so ours are going to pop up in line. Packages, if you click this tab, it'll show you anything that pops up in here you have installed on your computer, and if it's checked, that means that it's loaded into your environment for different packages. You can do it that way. The way we're going to interact with packages in class is through code, because it's reproducible and more easy to see what's going on. The other tab, the last one I'll talk about, is help. R's help is notoriously bad. I don't want to say bad. Not helpful. When the base help, like going over here and searching a function, is helpful is if it's a function you already are pretty familiar with, and you just need to like remind yourself what an argument name is or something, then you can find it. But if you're like trying to figure out how something works, just don't even open that can of worms. Go to the internet, ask ChatGPT, go to Stack Overflow, find a cookbook or something on R. Okay. Questions about RStudio? R in general? Okay, so we're going to work in what's called markdown files. This is like, maybe you've seen them as notebooks, or there's QMD, which is a Quarto markdown. There's RMD, which is R markdown. They are quite literally identical, except for the file extension and the defaults of what they spit out. So I'm in the process of changing everything over to Quarto, to QMD. So depending on how on top of things I am, you might sometimes end up opening an RMD and sometimes opening a QMD. Just know that they're exactly the same. Nothing's changing except the file extension. And it might look a little different when you output everything. What's cool about these markdown documents is they allow you to have text, just regular old text, and then code in the same document, which is nice in a class like this, because I can have like visuals and etc. and then code, and we're not like switching back and forth between stuff. And so when you see this white background, this is text, right? So R knows, because you're outside of this little block, that it's text and it's not code, and it's going to ignore it. Then if you're, and importantly, you probably have this source and visual switch up here. If you're in source, you'll see these like the backtick, 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 R, and then code, and then backtick, backtick, backtick. That backtick is on the tilde button on your keyboard. In case you accidentally delete them, don't accidentally delete them. If you accidentally delete them, then so if I delete that, now R thinks the rest of my document is code. It's like when you're reading and there's an open parentheses and then never a closed parentheses, and for the rest of your life, you're just in a parenthetical. That's like that. So, but it's simple you can just put them back, right? But if you get that weirdness, that's where that is. You can also create new chunks. They're called chunks by clicking this C button, and that'll pop up with a new chunk. And the reason it says R here is you can code in other languages in these as well. So you could like have Python in here, or C or Java or different stuff. We're using R. Questions on that? Yeah.
How is this different from like the default if you open like a file or a script in RStudio and it goes straight into?
Yeah, so if we go R script, right here, anything that I type, it thinks that it thinks that this is code. So if I try to run it, it's going to give me all kinds of errors. If I don't want it to be code, I have to put it in a comment.
Yeah, how do you go into like the .png format where you can type in it?
When you do new document, click the little down arrow and then open Quarto document or R notebook, or yeah. And you can see the other stuff you can do: Python script, SQL, stand, blah, 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 blah. Yeah.
If you're, say, like writing code for like your research, would you recommend doing it in R Markdown or like just R file? Because I've noticed I do it in R Markdown just because that's how I learned it, but I've noticed a lot of people will just do it in like an R file.
Yeah. It depends. Mostly I am writing in Markdown for my workflows nowadays because it has a couple of advantages. One, I can write sort of longer notes to myself and other notes and whatever in this, and it just looks nicer. It's not just a bunch of comments, and it's easier to like keep track of where stuff is. And you can output them to these nice documents that look nice. Granted, so like, let's say, for example, like some of my work, I have we're going to use this later in the semester. I have a model. So I have like the HBV model is like, I don't know, 100, 200 lines of code or whatever. And so it's a big chunk of R that is a function that I then use in my research. And so it doesn't make sense for that to be in a Markdown document. That's in an R document, and then I call that and have that function available. So if you had like a big script, you might think about putting that in an R document and having it do its own thing, or pull it into a Markdown when you use it. But yeah, the other thing that I really like about these is that, especially for like a long workflow or like a paper, you can run these chunks individually really cleanly. So it's not, when you're in a .r file and it's just script, like if you want to run things individually, you highlight them and then run them. Whereas this, I know if I click this play button here, this is going to run just the code in this chunk, right? So that's a good question. What else? Should we do the next thing? The next possible bomb to drop on the class? Okay, so so there's base R, right? Which is like, if you just open up R, don't do anything, it's what's available to you, right? There's a lot of functionality in R. Most of the stuff we're going to do, you could do in base R. However, there's the tidyverse is becoming, I would wager to guess, more popular than using just base R. So this is a package So what a package is like additional capabilities of the language that has been created by somebody else that you can load in and add that capability to R, right? It's like an extension of the original language. And we're going to use tidyverse. The reason we're going to use tidyverse, I think the way that it does things, I think is more powerful, but also easier to understand, especially the code's easier to read, especially if you don't come from like a computer science background and haven't done a ton of coding. Also, a lot of the like data manipulation stuff that manipulation's a bad word to use, like data wrangling stuff. The way it's set up, it looks really similar to like SQL or SQL, which is really nice if you then need to use SQL because you're like, oh, this looks similar to the tidyverse stuff. So that's why we're using it. So in order to do what we're going to do, we need to make sure that you have it, and then we need to load it. So there are two steps to using a package in R. One is to install that package. So that just like gets it installed on your computer, like installing a program on your computer. When you install a program on your computer, it doesn't mean that it's running all the time. It's just available to you, right? So that's what this does, this install.packages. You can check to see if you have tidyverse by going to your packages and either scroll or type in the search here, and you'll see tidyverse. If you do that and you see you have tidyverse right here, you can ignore this line. If you don't have it, then you're going to delete this comment. So that hashtag, that is telling R, I know we're in a code chunk, but don't run this. This is not code. So it's run out. It's by default, it's commented out because I don't want to reinstall tidyverse every time I run this. So if you have tidyverse, you're just going to click play here. If you don't have tidyverse, you're going to delete the hashtag symbol and then run, and it's going to fly through a bunch of stuff, hopefully. So at this point, everybody should be able to go to their packages and see tidyverse with a little checkbox. Now we have all this tidyverse stuff. So what we're going to do today, we do things a little bit backwards at the beginning, which is we're going to go through how to do some plotting. And then next class, we're going to step backwards and do like the intro programming stuff. The reason I do this is I think it's helpful to understand like why we're learning the intro programming stuff when we're learning it. And also to kind of like get a sense of what you're going to be able to do with all the plotting at the start, so that again, it's kind of clear why we're doing what we're doing when we move on to the next chapter. And again, so if you have a bunch of R experience, our intro stuff is basically this one and the next one, and then we move into the hydro material. So this is like a refresher if you're comfortable with all this. So the first thing you should have, this chunk should be populated already. Is that true? So just click play. And what you should see happen is these three data sets pop up in your environment. So this is reading the data from your project files, so these CSVs, into R. So now they're available to you. We'll talk about how to do this and what's going on here later. But for now, I'm just skipping that. Okay, everybody have that in there. Everybody can see these three in their environment. Okay, so let's make a ggplot. So we're going to look, we want to take the Pine data, which this is it's from the Pine watershed in Shenandoah National Park, and plot this. There's a stream flow column and a date column, and we want to show the time series as a line. So we just want to make a hydrograph. There's a couple different ways to investigate this Pine data. One is to just click Pine, and you can see it like a spreadsheet. And you can see we have our time is called date time, and our discharge is called CFS, for cubic feet per second. The other way you can investigate to just like, this is the way I usually do it, is click this little blue thing, and it'll show you what your column names are and what type they are, etc. So we can look at them and see we have date, time, and CFS. Why? Oh, I think maybe because I didn't. Yeah, okay. So the way that we want to do this, we want to use ggplot. And so ggplot is the plotting library that's part of the tidyverse. It operates a little differently from other plotting functions that you may have seen, or maybe you've used. Who's used ggplot? Okay, so almost everybody. So the way ggplot works is on what's called the grammar of graphics. So this is a way to construct graphics in a way that sort of allows it to have a grammar, so to speak. And so what's nice about it is I think it makes it a little easier to see the code and understand what's happening, rather than some other plot functions where it's just like plot, and you do like data X, Y, and then like 50,000 different arguments for what you want to specify about the plot. This breaks things down in a way that is, I think, when you see the code, you can kind of get a sense for what's going on in the code. And so the way this works is the first thing you give ggplot is the data you want to use. So in this example, we're using the cars data set. So that's this red box here. The next thing you give it is the mapping argument, which gets wrapped in a function, AES function. And what the things in the AES function do are tell you how to control different aspects of the plot. So at a bare minimum, you're looking at X and Y, right? But you can also put other stuff in there like color, shape, line type, all kinds of stuff that you can control with other variables, right? So in this case, we want the X-axis to be controlled by speed, the Y-axis to be controlled by distance, both of which are columns in this data set, right? This data portion, having this cars in here, tells R that speed and distance are here and tells them where to look for them. So without this argument, without data equals cars, R wouldn't know what those things were, and you would get an error. So now you have this setup where you have your X, you have what data you're going to use, what's going to control the X, what's going to control the Y. So if you ran it at that point, you would just get a blank space with speed on the X and distance on the Y. The next thing you need to do is tell it how to represent the data on the plot. And so we do plus, meaning like add, and then some sort of geometry. So in this case, we're doing geom point, which will show your data as points on the space that you developed with the ggplot line. So at first, this can feel kind of complex, but I think once you get used to thinking about plotting this way, it makes it a lot easier to see what's going on. So go ahead. So let's make a ggplot. So I'm going to write like the longest form possible ggplot. So we're going to, the first thing is ggplot. And if you type ggplot and this doesn't pop up like this, this means that you don't have tidyverse installed. And you can notice that when you type it, it shows you what the format is. So you know that you need to have data and then mapping, etc. So that's really helpful with different functions that you're going to use. So ggplot data equals, and our data is going to equal pine. Then the next argument, and because in R, line returns don't mean anything. It doesn't care. And so because my text is really big and this next part would go on to multiple lines, I'm going to hit return just to make this look nicer. Mapping equals AES, X is date time, Y is CFS. So don't run this, but if I run it, what would you expect to see? Will it do something? It'll do something. What's it going to do? Yeah. It's going to show me a blank plot because I've told it how to set up the space. I just haven't told it how to show the data. Right. So I have this blank setup, and then I want to add, I'm going to tell it to show my data as a line. So I'm going to do a plus and then geom. And notice when you type geom underscore, it auto populates all these different or gives you an option to auto-populate all these different geometries that you can use to show your data. So you can type line or go all the way down to line and hit enter. And this function just has parentheses at the end of it. You can put a lot more detailed information in there, but if you don't need to specify anything more, you can just leave those two parentheses blank. But the two parentheses are very important because the two parentheses signals to R that this is a function, right? If you don't have the parentheses, then R thinks that that's an object in your environment, right? So if I were to type geom line with no parentheses, this is going to give me an error that says object not found. Or, oh, because it's a function, it spit out the function information. But if we try to run it here, it would say object not found. So to tell it it's a function, do that, and then it'll run that function. So now we can hit play and we get a plot. Okay, so now let's play with some the way we can change some things about the plot. So we're going to make the same plot, but we're going to show the data as points and then use the PCH parameter to change to a different point type. Okay, so why don't you get some practice and see if you can look at the previous statement. At this point, don't copy it. It's good to just like type, but type out the statement. And then what's the one thing we're going to change if we want to change it from a line to a point? Yeah, it's going to be geom point instead of geom line. So at the first step, just show our data as points instead of lines. We got it? So within those parentheses, we can add additional information to tweak stuff, right? So in this case, there's an argument called PCH that'll change the point type. And you can, this is in the, it's in help files in R from the like parameter or plot option help file. It's a little buried, but the way I would do this, honestly, to look it up, I'd go into Google and type, change point type in R, and it'll show you these codes. But these are the different codes for all the different points. So you can pick one, put the number. I'm going to do 3. And you can see that it changes it to pluses. So there's all kinds of stuff you can do. You can change the color, you can change the line type, the line thickness, all sorts of stuff. Okay, so this is where things get fun / confusing or anger inducing. So let's try to change color. Okay. So I'm gonna, again, just to get practice typing these things, I'm gonna go ggplot. Instead of copy and pasting, I'm gonna do data. Well, I'll type it. Data equals pine, AES, X equals date time, Y equals CFS, plus geom line, and run. Now, I want my line to be blue. So I decide that I'm going to come in here and say X equals Y, or X equals date time, Y equals CFS, color equals blue. And look, it confirms to me that blue is blue, which is fun. Okay, and then run that. So that R decides to troll you or gaslight you. It's like, not only does it ignore you and make the line red instead of blue, but it also tells you that red is blue. Anybody know what's going on here? This is very understandable and predictable behavior by ggplot. Okay, so that color needs to happen in the geom line. That's true. But why? Okay, because that's what's drawing the line. But we can control color from that AES, and we will later too. But it just depends on how we want to control color. So when earlier I was like, I'm saying ggplot, my data is pine. When I read the aesthetic line, what did I say? Like, how did I read it out loud to you? Do you remember? How to set up the space, right? So I said x equals, I would read as x is controlled by date time, right? And then I said y is controlled by CFS. And then I say color is controlled by blue. Does that make any sense? No. So what I'm saying here is, okay, ggplot, I want you to control the color aspect of this plot using the value blue, right? Now, I'm basically telling it that blue is data, right? And when R is given two vectors that are differing lengths, right? So date time is 2,160 elements long. Blue is 1 element long, right? What R does is it repeats the shorter vector until they match, or until they come up to each other. Now, if you if the short one isn't if the big number isn't divisible by the short one, so they don't match once it repeats them a bunch, you'll get a warning that says object isn't a multiplier. I forget exactly what it is, but you'll get a warning. The more dangerous situation is when it does it, but it doesn't give you a warning because they match in this case, because one, it just repeats it to it. So what this is basically doing is creating another column that just says blue 2,000 times, and then using that to label this line, and then giving it a color that is the first color in its default color scheme, which is red in this case. Right. So it's a little complex what's happening. And I think it'll be clearer once we intentionally use this argument. But to give you an example, right, in this case, it's a little confusing, but I could also say like banana, and like you can see all it's doing is making the plot red because that's the first color in its palette, and then labeling it whatever you put in there, right? So we could even make this make sense and say pine, right? And now it's just labeling, it's saying the red line is the pine data, which is true, right? Not a great plot, but right. So the way we can fix this is take this color argument, get it out of there, and then go down to geom line and do color equals blue. And now that'll actually do that. So if you get really like wonky and unexpected results from your plot, just reconsider how you've set it up and that it could potentially be incorrect.
Does geom take call and color as the same thing?
I believe so. I think it probably also takes. Okay, so let's do this. First, we're gonna make the same plot as above and the line blue. So let's do what we would really do in real life, which is copy this code and then paste it. And we're gonna change some stuff about this plot. We're gonna make it a good plot, and then we're also gonna show how you can use that color argument in the aesthetics, that AES statement, to actually do something useful. So the first thing is that like when we make this plot, the default ggplot theme is terrible. It's ugly and gross, and you shouldn't ever use it. Why? Does anybody know why? It is like pretty well accepted that it's bad. Why did they do it? But I guess first, well, let's talk about why it's bad first, and then we'll talk about why they did it. Why is it bad?
The gray background.
Yeah, the gray background. What else? The lines, right? there's no best practices, right, are to not have anything in the plot space that isn't necessary, right? The Tufte calls it chart junk, right? So like, there's no reason for this to be gray. And there's no reason to have all these lines because they're not referencing anything specific, right? And if suddenly you did add, like, let's say you wanted to put a horizontal line at 750 because that's a 10-year flood or something, then it looks extra crappy because there's like different lines in different places, et cetera. So ideally we would have nothing in there. What else? So we're going to change this. There's a bunch of pre-existing themes that you can use to change ggplot. So we're going to type theme underscore, and you can see all the different ones, and you can try different ones to see what you like. But theme classic is the one that I always use, unless I have some specific reason to use something else. When you're going to put color in your aesthetic is when you want it to be a dynamic aspect of your plot, right? So in this case, now this is not like a great plotting practice, but we can do it. We can take the color and control the color using CFS. So if we do that, this is saying, I want you to control the color of my plot with the CFS variable. So it takes that, creates a color ramp, and then maps it to CFS. So now, as your CFS gets higher, it gets brighter blue. As it gets lower, it gets darker blue. And you can, there's all sorts of color ramps and you can change all that, whatever. But it's smart in that it will, as we'll see later, let's say you had like multiple watersheds in here, you can say control the color with watersheds. It'll notice that that's a factor label that just has like 3 potential values, and it'll make that a categorical ramp. But in this case, it sees that it's numbers and should be a continuous ramp, and so it does that and just figures that out for you. I'm going to show you another, so where this color thing comes into play, and where the, like, I said that you can make multiple plots and put them on top of each other, and you can do that in a really straightforward way in ggplot, which is kind of cool. So we're going to show that. We're going to switch to a different data set, this SNP data set. And that stands for Shenandoah National Park. And if you look at it, it looks very similar. We have station ID, date, time, CFS, that's all the same. But if you, actually, I guess I was gonna do this a little differently. Well, we'll look at the data first, but if you scroll down a bunch, you can see that there are multiple station IDs. This is actually 2 different watersheds in the same file, and they have an identifier with them. So if I go into this and I do the same thing that I've been doing, which is ggplot, data equals SNP, AES, X equals date time, Y is CFS, geom_line. This is what we get. Anyone explain what's happening here? Yeah, it's plotting 2 separate data sets, but it doesn't know, you haven't told them they're separate. And so basically for every timestamp, there are 2 values. And so it's going like this between them, right? So you look at that and you're like, that does not look right. And then you would look at your data, see what we just saw, which is that there's 2. And then we need some way to separate them, right? I want to look at both of these watersheds. There's 2 different, well, there's probably 1,000 different ways to do this. I'm going to show you 2. One is using that color variable, right? So if we go to SNP, we have this station ID column, which tells you which, for each measurement, what watershed was it from, right? And so I can say, well, hey, I have this variable that tells you which one's which. Control the color using that, right? So I can go color equals station ID. Right. And you can see, right, it separates them, it assigns one blue, one red, gives you a legend. So this is, like I mentioned before, it automatically figures out this is a categorical variable. I need to give you 2 categories, assign a color to each, rather than doing a color ramp. Okay. But let's say, well, even here, you can see why it might be helpful to separate these, right? Because look at that storm at the end of January. How high does NFDR get? I don't know. I can't see it. They're smushed together, right? So a better way to look at this would be to spit them out into two separate plots, right? Lots of different ways to do this. There's a real fast way, which is our ggplot has a way that you can say, hey, instead of like control color with different variables, make a different plot for each different variable. So we're gonna go ahead and get rid of this color argument and start from square one with geom_line. And then the way we do this, it's called, when you split plots up into multiple plots, it's called faceting the plot. And so we're gonna type facet. There are multiple different options. The one we're gonna use is facet wrap. And what you basically do is tell it what column are you going to use to split up the two graphs, and then how do you want them to be? Do you want them to be on top of each other or next to each other? And so we're going to use, so there's a facets argument, and oddly you have to put the station ID in quotes. It's just one of those things, you have to do it. And then there's two arguments. One is nrow and one is ncol. You could use either one. They stand for number of rows or number of columns. I want them on top of each other, so I could say ncol equals 1, so that they're one column on top of each other, or I could say nrow equals 2 because I want them in 2 rows. So I'm going to do nrow equals 2 and hit play. Just because it's fun, show you. So you don't have to do theme classic for every plot that you do. You can use theme set. Just at like the top of your document, put theme set and then do theme classic. And once you've run this line, any plots that you run after that will always have the classic theme, which is nice. Oh, I forgot to show you how to change the axis labels. I was going to do that earlier, but let's just do it now. Like anything else in ggplot, there are multiple ways to do this. One of them is to say, let me make sure I do this right. Xlab. So our Xlab, maybe we want to say date, Ylab, discharge, CFS, always pluses after. What if I want to have different variable lengths on my y-axis? Not variable lengths, ranges. Yeah. Thanks for asking that. Yeah, so whatever you wanted, so by default, it sets the y-axis to the same, right? And if you're comparing the same variable, that's a good practice, right? But let's say instead of NFDR and Pine, you had discharge and conductivity, right? So you're plotting two very different things. If you plot conductivity on the same scale as discharge, one's going to be a flat line and one's going to have a bunch of variability, right? So in that case, you want them to have the y-axis range set based on the data. And so we can do that as an argument in facet wrap, which is scales equals, oh boy. Yeah, free underscore y. So that makes the y, and now you can see the top one has a different scale than the bottom one. Another thing that is useful is like when I make plots with dates, I typically don't label the x-axis because it's like apparent that they're dates, and it takes up space, especially in like a multi-panel figure. And so we can get rid of it by just like putting empty, ooh, that didn't work, empty parentheses, right? But if you do that, the space where it used to be is still there. And so they have this option in ggplot where you can tell it, just get rid of this entire element. And to do that, you type element blank, and then that'll actually like get rid of it altogether. And then you now have like the bottom boundary is closer. So if you're making a multi-panel figure, now your plots can be closer to each other and not take up as much space. Yeah.
In the same way with the.
Okay, so we had this data set SNP that has two series of discharges. Ideally. Come on now. Okay. So it has this data set that is Pine, and then the second one, which is NFDR. So there's two discharge data sets stacked on top of each other. And so to differentiate them from each other, we did this facet wrap and told it to split them up based on the IDs and station ID. Cool. Yeah, so the question is, would it, if you really just had two, would it be better to split them? And I mean, I would say it depends on the situation, but facet wrap does some nice things for a multi-panel plot that would otherwise take a whole bunch more code. So like notice the x-axis labels are gone for the top one. They're labeled. They have the box labels. The y-axis labels don't repeat. And then if you want the scales to be the same, it's really easy in facet wrap, right? Because if you don't do the free Y, then your scales match perfectly. So there's all this stuff that it does by default that you don't have to do if you use facet wrap. So it kind of depends on how you want the plot to look and everything, but often it's just a nice, clean way to do it in a short amount of code. Okay, so you can also facet with two different things. So we just faceted on the name of the watershed, but we can facet on other things as well. This example is kind of dumb, but I didn't want to load like a whole new data set just for one example. So we'll work through it and we can see. So let's just set up a plot again. So we're going to do ggplot, not ggplot. ggplot data equals SNP, AES. Y is going to be CFS, geom line, and again, we could run that and we'll get that wonky line. This is not good. My computer's on the struggle bus for some reason. That shouldn't have taken that long. We'll get that wonky line, right? Because it's connecting all the dots between both watersheds. But we want to do a grid, and what we want to do is we're actually going to make this so that it's going to split them up based on what watershed they're in, but we're also going to make a plot for each month in the data set, right? So I can do, in this case, there's facet grid, and I want station ID, and then we're going to do this tilde sign, which is kind of like by and month. So there's if you look in here, there's a month column. So that's easy for us to use. So we're saying split up the plot by station ID and by month. And we're going to do scales equals free. So otherwise, it'll just, actually, I'll show you what it looks like without that, and then we'll add it. All right, so by default, facet grid makes your the scales on your X and Y axes match for all panels. So it's showing the entire time, even though it's only showing the individual months. So if we do scales free, it'll fit those Y axes to, or X axes to the individual months. And again, this isn't like a super useful plot, but in different situations, this can be really helpful. Oh yeah. So this is the classic theme, right? Which, as we talked about, is less trash than the default theme. And to set a theme for your whole document or any code you write after that point, you can do theme set and then put the theme you want, the function for the theme you want in there. So this would be theme classic. That'll get that. And this is really nice too, because even you can load custom themes, you can develop your own theme. Okay. I'm gonna do a few more things here. First, to just illustrate, we're gonna use box plots several times throughout class. Sorry. I'll just wait. Sorry, it just like short circuits my brain when I can hear other people talking. That's why I said campus. Okay, cool. What is it? Probably you may need to run library tidyverse.
I necessarily did they said also I
Okay.
forgot again.
Well, so installing it and running it are two different things. So, or installing it and loading it are two different things. So when you do the install.packages, that's like installing a program on your computer, right? And then, but just like with a program on your computer, if you don't open that program, it's not just running all the time. So at the beginning of any document where you want to use tidyverse, you have to do library tidyverse. And that actually like that loads it so that your code can use it. If we want to set this up, right? We know we want to make ggplot, data equals AES, X equals Y equals. So our data is still SNP, right? So we put that there. So what's my X? Yeah, what's station ID, right? So like you're right, watershed, but it's called station ID. And what's my Y? CFS, right? So it's cool. And then we want to show this as a box plot. So there's two different ways you could do this. You can do, again, if you're not sure what it's called, I would do like geom underscore and then just search for box plot. There's also stat box plot. I don't think that they're different. You can use either. In the notes, it's stat. I'll use geom here. And you can do that. And we get something. Ooh, they don't look very boxy. Yeah, where first think about a stream, right? Where on what range of the flows is that stream almost always at? Yeah, very small, right? It's low. Almost all the time streams are low, but then when they get high, they get real high, right? Like orders of magnitude higher flow. And so because of the high flows being so much higher than the low flows where or medium flows where most of your time is spent, we have boxes there. They're just smushed, right? And this is really common in hydrology because of that like characteristic of watersheds of stream flow. So what could we do to make it so we can see more information about this down here? We could change the range. So we could make it so that we can only see that little bit. What if we want to keep seeing the high values too? Oh, yeah, we could split it by time. So we could just look at base flow type times, which would be similar to just cutting the range. We could make a break in the axis. That's really complicated. I don't want to do that.
CC.
Ooh, we could log transform the y-axis, right? Unfortunately, it's going to take some time. This is complicated. Hitting scale y log 10 is a function in ggplot. Importantly to remember in R, log is natural log. So if you want log 10 or base 10 log, you got to do log 10. So scale y log 10. Aha. So now we have now we can see differences. Cool. Okay. These last couple follow along, but I'm gonna go through relatively quick because it's just kind of some show and tell. They're not like core concepts that you're gonna use all the time, but I just wanted to show you some stuff. So I'm gonna just get a plot set up. We're gonna use this RBI data set, which stands for Richards-Baker Index, which is a measure of flashiness for a bunch of different watersheds. And so the first thing I'm gonna do is plot RBI versus drainage area. And we're going to do geom point. So cool. But I want to make this more rich. I want to do some other things. So I'm going to go ahead and change the size of the points based on the average temperature at the site. Right, so now we're mapping the temperature. So higher temperatures at the site become a bigger dot. We can also, I want to change the color of these to make them each colored. I'm going to color them by state, what state the data is from. But when you're coloring points, often it helps to have like a black background around them or a black line around them. So we're going to use a different point type that has that. So PCH equals 21. The 21 point value is a circle, but it has a background value and then an outside value. And so instead of doing, so if we do color, it'll change the outside value, but we want to change the fill value, which is background, which you change that with BG equals. So I'm going to do BG equals state. So that changes the background color. And then what problem do we have now? So we have kind of a cool looking plot. But what issue do we have? Yeah, especially down here, the points are really on top of each other. So it's even tough to tell like how dense. Are there a ton of points there? Is it just a few overlapping? And so we can make them transparent. And that parameter is alpha. So I'm going to make them 30% transparent. Or maybe that's 70% transparent. I can't remember. I always just play with it until it looks the way I want. And now you can see through the points a bit. Last but not least, you can also show stuff in you can use multiple geoms. So you can show multiple. So like in this case, right, you have like a box plot, but you also want to show them as points. You can do multiple. You can like build them on top of each other. So I'm going to show that. So again, ggplot, we're going to use that RBI data. And so this is a similar setup to what we just had. I'm going to set the color of the points based on this parameter called AGG ecoregion. And geom point. All right, so we can see we have two data sets here, Northeast and SEC ST plane. I don't know what that means even, doesn't really matter. So we have the blue and the red. And again, this is like not the best thing to do, but we're just showing and telling. But you can imagine like you want to see what does the line of best fit look like for those two things, right? And so what we can do is, and I'm going to put this behind the points because it renders them in order. There is a function called stat smooth that will fit a line to your data. By default, it'll do like a low S fit where it kind of goes like wavy. But you can force it, you can tell it to do a linear model. So you can do method equals LM for a linear model. And then I'm just going to type line type equal 2, and that'll make it a dashed line. Be sure we have a plus after that. Ooh, I have an error. Everybody look at it. Here. How could you tell? Or did you just look at it? Yeah, so when you see unexpected symbol in, that's most of the time you missed a comma. Because it read LM and then it's still reading the method argument and then it sees L and it doesn't know what to do. Or sees line type.